Dear students, our subject is physics. My name is Gadvi sir. I have been teaching physics for many years. In short, I would like to say this subject is very much interesting, but it requires a lot of intelligence, higher level of intelligence. It requires brain, it requires hard work, it requires planning. But we will do it, and I hope you will do it. Doesn't matter whether you are studying with A or B group, physics is a compulsory subject and it has to be studied. It must be studied. Okay. In physics of 11 science, there are 15 lessons. I am going to give you the names and short introduction to these lessons. Please be careful. Take your notes and pens so that you can write if some important things are there. Lesson number 1 in physics of 11 is this is our first lecture. Lesson number 1. Name of the lesson is physical world. Physical world. This lesson will give us the information about all other chapters of 11th and 12th science. In fact, the lesson is informative lesson. Lesson number 2 is units and measurement. Units and measurement. Children, I think you know something about units and measurement. We need to measure things in physics. We need to measure things in our life. We need to measure physical quantities in technical purposes, in industries. So measurement requires physical quantities, and physical quantities to be measured require units. For example, if you are asked how will you measure mass, you will say that mass can be measured in kg, means kilogram. If you are asked time, physical quantity time, how is physical quantity time measured, in which unit it is measured, you will say that time is measured in second, time is measured in hours, time is measured in minute. So these are called units. A standard which is required for the measurement of a physical quantity is called unit. In this lesson we will discuss about some systems of measurement, some ancient systems and international system of units, which is SI. Then lesson number 3 and lesson number 4. Third is motion in a straight line, and fourth, motion in a plane. Motion in a straight line and motion in a plane. These are not two different types of motion. First of all, you get the word motion. You know very well about motion. In 9th standard you studied motion. When an object moves along a straight path, it doesn't change the direction during the motion, during the period of motion. It is called motion in a straight line. It means one dimensional motion. You know these types of motion: one dimensional motion, two dimensional motion, three dimensional motion. In short, they are known as 1D, 1D, 2D, 3D. These are the words we use them in our daily life. So friends, when an object moves in a straight line and doesn't change the direction, the motion is called one dimensional motion or linear motion or motion in a straight line. Now think about the motion of a vehicle moving along a road. Road is a surface. The vehicle can change its direction. It takes turns whenever required. Motion of a living object, any insect which moves on a wall. Wall is a surface. It's called plane. Any surface is called plane. Ground is called plane or surface. In this case, there are two axes. The motion of such an object can be described into two directions. X and Y axis can be used as reference for such motions, and therefore it's called two-dimensional motion or motion in a plane. In short, we will discuss about motion in 3D, means three-dimensional motion. In short, in this lesson, fourth lesson, we will discuss in short about 3D. For example, a butterfly moves. Its motion is 3D or three-dimensional motion. An aeroplane moves, flies, three-dimensional motion. It can change its direction anywhere. At any point, it can change the direction. And there are three directions to move, and they are x, y, and x-axis in physics. Then lesson number 5, in which we will discuss about the laws of motion, rules of motion. Lesson number 5, laws of motion. Dear friends, you know about the laws of motion. In fact, these laws are so popular that everyone who went to school at least something knows about these laws. You know something about Newton's laws of motion. In fact, in the beginning of 17th century, Galileo Galilei studied motion in detail. He worked hard to understand motion. He worked hard to understand nature, rules of motion, laws of motion. But throughout his life, he couldn't derive any rule or law. As we all know, he left in 1642, and a great scientist, Sir Isaac Newton, born in the same year, and after some years, he derived during his studies 3 laws of motion, and we call them Newton's laws of motion. So in this lesson, laws of motion, we will discuss in detail laws of motion. These laws are so popular that everyone who went to school knows at least something about motion. Even you know something about these laws. Well, we will study them in detail. Now lesson number 6. Work, energy and power. If we complete the concept of force in this chapter, laws of motion, we will discuss about force, and if we understand force properly, then we will be able to understand work. because this work has connection with force. This is not the work we use widely in our daily life. When we do our homework, when we cook food, it's not work in physics. Here the concept of work is the work done by the force. When an object is given some force, is applied some force, it moves from its original place, it changes position. Then we can say that the work is done by the force. So the concept of work is different from the work we know. And if we understand work, we will deal with energy, because the words work and energy are connected with each other. When work is done, energy is transferred from one object to another. You also know many types of energy, like potential energy, kinetic energy, mechanical energy, electrical energy. These all are energy. Heat energy. These are types. We will discuss how energy is transferred, how energy is converted. Energy can never be created. It can be converted only. It can be transferred only, as you know. Then power. This is not the power which we use for some people. My friend is very powerful. That's not power. In this chapter, the concept of power is related to energy. When the energy is transferred, when the work is done, power is measured as the rate, as the speed of transferring energy from one to another. When a given work or the task is done in a short time, then power is more. If the work is done slowly, it takes more time, then the power is less. It means power is nothing but the speed of transfer of energy, speed of work to be done. Power is rate of transfer of energy. Power is defined as the ratio of energy to time. Okay. Then lesson number 7. It's system of particles and rotational motion. System of particles and rotational motion. Students, you know that each and every object has been made up of particles. So the object is known as system of particles. An object is known as system of particles. And such a system of particles perform different types of motions. For example, our fan is an object, is made up of many particles. When we switch on the fan, its blades start rotating without changing the place. The blades rotate about the axis, and axis is nothing but the shaft or the rod about which the blades are rotating. This type of motion is called rotational motion. First, we will discuss about motion in a straight line. Then in fourth lesson, we will discuss about motion in a plane. Then we shall discuss about laws of motion, force, then work, energy, and then rotational motion comes. So it will take more time to reach the lesson number 7, rotational motion. Well, many examples can be given for rotational motion. Our earth Whenever earth revolves around the sun, it's called circular motion. It's not rotational. It forms a circle, and hence it is known as circular motion. But when the earth rotates about its axis, its motion is called rotational motion. So the earth performs two motions simultaneously, circular motion as well as rotational motion. Okay, then in this lesson also, like force, torque will be explained, energy possessed by the object, energy to rotate, that is rotational kinetic energy. Okay, all these things will be studied in this lesson. Now lesson number 8, that is gravitation. Gravitation. My dear brothers and sisters, you know something about gravitation. When an object is released or dropped, it moves downward towards the earth. It means there is something in the earth which attracts the objects towards it. Similarly, our earth is attracted by the sun, moon is attracted by the earth. This is a type of force, and that's gravitational force. Any object which has mass produces gravitational field, and this gravitational field is responsible for the production of the gravitational force. In this lesson, Newton's universal law of gravitation will be explained in detail. An interesting lesson. We will discuss it after lesson number 7. Okay, lesson number 9 and lesson number 10. Mechanical properties of solids, and lesson number 10, mechanical properties of fluids. Children, you know that solids and fluids are called matter. They are types of matter. You know that matter is divided into 3 types, is classified into 3 types: solid, liquid and gas. Liquid and gas are combinedly known as fluids. So thus there are 2 types, solids and fluids. These are matter. They possess particles. These particles have different properties: properties of motion, speed, flow, properties of elasticity, properties of changing or changing in shapes, properties of reformation. All these things will be discussed, means things about matter, properties of matter will be discussed in detail. Theoretical lessons, mechanical properties of solids and fluids. Now lesson number 11, thermal properties of matter. Thermal properties of matter. And another lesson, lesson number 12, thermodynamics. In fact, lesson number 11 is a basic lesson to understand thermodynamics. Thermal properties like heat, temperature, change in temperature, such things will be explained. We will understand in this lesson what is the basic difference between heat and temperature. Perhaps you know that temperature is nothing but the measure of hotness. How much hot an object is. The answer gives us the value or the measure, that is known as temperature. Also we will discuss about units of temperature: degree Celsius, Kelvin, degree Fahrenheit. These things will be discussed in this lesson, okay, as basic things required for the knowledge of thermodynamics. But in thermodynamics we will discuss about the laws of thermodynamics. There are some laws, as we discussed in lesson number 5, laws of motion. In the same manner, there are some laws of thermodynamics. We will discuss them. We will discuss heat engines, refrigerators, Carnot cycles, Carnot engines in this lesson in detail. Another thing is, for your knowledge, I would like to say, thermodynamics is not just a chapter, it's a branch of physics. In fact, there are many branches of physics which we will discuss in detail. Now lesson number 13, kinetic theory. Kinetic theory. This lesson is related to gases, exclusively gases. Kinetic means related to motion. In air, molecules of different gases move continuously. Why? We should think about it. They possess energy, they have heat, they perform different motions. In this lesson we will discuss about laws: Boyle's law, Charles' law, Avogadro. All these things will be discussed in this lesson, but at the end of the year. Okay, then lesson number 14, which is very interesting lesson, called oscillations. Oscillations. In fact, some object perform oscillatory motion, and in short, oscillatory motion is known as oscillations. You've seen one thing, that a pendulum of a wall clock performs its motion in this manner, This motion is called oscillatory motion, or we can say that the pendulum performs oscillations. You can give many examples, you can take many examples for this motion, but we don't know the actual logic, the force required for this motion. How does an object perform such a motion? So this lesson will give us vast knowledge of oscillations. Okay, once we complete oscillations, we will start entering waves. We will start understanding waves, because oscillations is the base of waves. Oscillations, base of wave. I am writing here lesson number 15, waves. Waves are always with us. We live with waves. For example, I would like to say, when I speak, my tongue behaving as an antenna it emits waves, and these waves propagate through the medium, through air, reach your ears, and your ears behaving as receivers take or accept these waves, and you can hear or listen. Similarly, with our eyes we see the objects. Light waves from any object enter our eyes, and due to refraction done by our eye lenses, we can see the objects. Images are formed on the retina of our eyes. Also, in mobiles, in TV channels, in radio channels, waves are used. Our internet works on the base of waves. So without waves we are nothing. At present, waves are most important. They play most important role even in our daily life. So how they work, how waves are explained, how waves are formed, how they propagate, should be understood clearly and carefully. So in this lesson we will discuss about waves. Also, oscillations and waves are important and basic lessons for our 12th science. So this is our 11th science, physics. We will start our studies from lesson number 2, units and measurement. This is the fundamental lesson. We can't imagine studying physics without units and measurement, as I already told you. Well, we will start second lecture in a very short time. Till then,